Part of the exam is calculator, part of the exam is not calculator. Part of the exam is multiple choice, which is a little bit odd. And you might think that's good. I don't know how you feel about it, but there's no partial credit on multiple choice. So some of you, kind of survive as partial credit. Some of the test is free response. So you will get partial credit on that part. Okie dokie. Markers. All right, here we go. Let's do the mini review. The ones that aren't marked out. These are all questions on the exam. If we're talking about it today, it is on the exam in some shape or form. Everything on the exam is on the review sheets. Everything on the review sheets is on the exam. So if it's not here, you're not going to worry about it. If it is here, you are going to worry about it because it's on the test. All right, so find the remainder. What does that mean? I'm looking at number 1 on the mini review. What does that mean? I'm going to do some division. And the easiest division to do is probably synthetic division. Now, you do want to be careful because remember, if there's any powers missing, you have to put in a 0, right? There aren't any powers missing, so we're good to go. All right, double check my arithmetic. Did I copy everything right? Okay, so negative 8, negative 16, positive 32, negative 7, negative 24. I think negative 76 is the answer. If you don't know what I'm doing, or that looks unfamiliar to you, you need to put a star next to it because that's what you want to go back and study. That's what you need to study. Find the y-intercept. Well, we just spent quite a bit of time finding y-intercepts for things we were graphing. How do we find y-intercepts? How do we find any intercepts? To find intercepts, period, we need to let, we need to let something be 0, and for the y-intercept, we need to let x be 0. That's right, because we want a y value. So if we put 0 in here, what is anything to the 0 power? Ooh, that's knowledge from a long, long time ago. Anything to the 0 power is 1. Good. So this is 1. That right there, 0.8 to the 0, is just 1. So what is my denominator? 4. So I have 14 over 4, which is 7 over 2. So your y-intercept would be 7/2. Now, this is an entirely different looking equation, but the directions are the same. How do we find a y-intercept? We let x be 0. So we put 0 in, and work it out. 0 plus 3 squared. Looks like this one's negative 18. So it doesn't matter what the equation looks like. If you are finding a y-intercept, you are going to let x be 0, no matter what.
When we write the answer, is it like y equals negative 18 or is it y-intercept?
These are going to be multiple choice questions, so I have a feeling it's either going to say negative 18 or it's going to say the point 0 negative 18. All right, number 3. You have a function, and you are to find f of x minus 1. Now, what does that mean? When we say we're going to find f of something, what do we do? Yes. Plug it in for x. That's exactly right. So it's going to go in here, and it's going to go in here. So we're going to have 3x minus 1 squared plus 9x minus 1 minus 2. Whatever you are f-ofing, that goes in for x. In this case, it's x minus 1. This is a FOIL, so please do not get careless. This has to be FOILed out. If you can do it in your head, that's fine, but if you can't, write it down. We're distributing, we're going to do more distributing, and we're going to collect like terms. So I got 3x squared plus 3x minus 8 if I did that without making mistakes. Easy, easy, easy. F of, plug it in. What if this were an H? Would that make any difference? No. That letter means nothing. You don't even worry about it. Just plug it in. Again, you're keeping track of what you need to go back and study. All right, find the inverse. Who remembers how to do this? There are some very definite steps we need to follow to find the inverse. Anybody remember? Aiden?
This one where you times 6.
No. We're going to first of all think of that f of x as a y, and then we're going to switch the variables. So x equals 2y minus 1 over 6. Remember this? That's the purpose of review, is to jog your memory. All right, here we go. Now we're going to get y by itself. So yeah, Aiden, I do bring the 6 over now. And then I'll add 1. And then I'll divide by 2. And there is our inverse. The notation for that, again, this is going to be a multiple choice question. So again, that would be the notation, the actual notation.
Wasn't there like a longer way to do that?
Huh?
It was like 2 ways to do that. Like that was the easy version.
No. There are longer problems than this, but this is how you're going to do this problem. All right, number 5. We should not have forgotten this. How do we find the vertex of a parabola? This is a parabola, x squared. How do we find the vertex? We have a formula. What's our formula? Negative
b over 2a.
Negative b over 2a. That's exactly right. So x equals negative b, which would be 6, over 2a, which would be 6. So my vertex has an x coordinate of 1. And then what do we do? Because the vertex is a point, we plug it in. So when we plug it in, we square first. So 1 squared is 1 times 3 is 3. Minus 6 times 1 plus 1. So what is that? Negative 2. And that is your vertex. Okay, every single one of these is an exam question. Paying attention. All right, number 6, we're solving. Does it tell you how to solve it? No, just to solve it. Solve it any way you want. What kind of equation is that? Quadratic. I don't think it's going to factor. If it factors, go ahead and factor it. I don't think this one does. So what am I going to do? Quadratic formula. Have to have it memorized. How dumb to miss this question. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's under the radical? Let's see, it'd be 9 minus 40. negative 31? What happens when we have a negative? I, and there's the answer to the question. Number 9, if they're marked out, you're not responsible for them. Number 9, that last number in the problem is really important, and it's not there, at least on my copy. So it's 3x to the 4th minus 8x squared plus 9x minus 2. And we want to know the possible rational roots, otherwise known as the PRRs, right? So what are the PRRs? All the factors of 2, which would be just 2 and 1, don't forget the plus or minus, over the factors of 3, which are 3 and 1. So if we're actually listing those, we want all the combinations of that big fraction. So we have plus or minus 2 over 3, 2 over 1, 1 over 3, and 1 over 1. All the possible combinations, this over these and this over these. Factors of last over factors of first. Consider the square root function. Oh my goodness. Oh my goodness. Who can airdrop for me the square root function? What's the square root function look like? That, I think, Lauren, what you're doing is the exponential there. Yeah, the square root function is this one. Remember your BFFs, kids? You can't forget about those. Those were a huge part of our work, and we need to remember them. All right, so we're dealing with the square root function. What is the domain of this function? Tell me about the x's. Where do the x's start? At 0? And they go that way? So the domain is x is greater than or equal to 0. Now what about the y's? Tell me about the y's. Where do they start? 0? They have the same, the range and domain are the same. Well, domain's x, range is y. Now what about zeros? Anybody remember what the word zeros means? What does it mean to be a 0? An x-intercept. That's the same thing as x-intercept. It's where you cross the x-axis. Does this one have a 0? Does it cross the x-axis? Yeah, at 0. So it has a 0 at the origin. That is also its x-intercept, right? Those are the same thing. Zeros and x-intercepts are the same thing. What about y-intercept? Yeah, isn't it that same point? Would you say that function, that particular one, is increasing or decreasing? Increasing. Because as you draw it, what is your pencil doing? Going up. So it is definitely increasing. Does this particular curve have any asymptotes? No. There are no asymptotes. Most of your BFFs do not have asymptotes. There are a couple that do. For example, the logarithmic curve has an asymptote right here, right? Would you say that is bounded in any way? Now remember, bounded means it has a ceiling or a floor or both. So you can be bounded above if you have a ceiling, you can be bounded below if you have a floor, or you can be bounded if you have both. Does this have a ceiling or a floor? Definitely has a floor, right? It doesn't go past this. So we would say it's bounded below. Your choices are bounded below or bounded above, right? This one's bounded below, and it's bounded below at y equals 0. That's as low as it goes. That's its floor. Doesn't go below that. All right. Let's take a look now at the actual review sheet. That's the next page of your packet. This is really current material for us. You're not asked to graph the thing, you're just asked to find the vertical asymptote and the horizontal asymptote. So what do we have to do here? We have to factor the bottom, absolutely. And if the top factored, we would factor it too, but it doesn't. Jacob, you awake? Okay. Nothing cancels or anything, so there's no holes, but that wasn't the question anyway. What are the asymptotes? Tell me about that. Do we have any asymptotes? I have a vertical asymptote at x equals -1. I have another vertical asymptote at x equals 5. Because vertical asymptotes are when the denominator is 0. And since there's two things down there, there would be two vertical asymptotes. In our notes, when we did all this, we graphed some like that, and this is where you get that really weird stuff going on. You have something over here, and something in the middle. You're not asked to graph this. You're just telling me where the asymptotes are. So the vertical asymptotes are wherever the denominator is 0. Now what about the horizontal? What? No, the horizontal is 0. And the reason that the horizontal is 0, this is a little tricky, but look at your original problem. What's the highest power we have? X squared? You don't have one on the top, right? It's tempting to look at these, but you can't. The powers have to match. There's no x squared, so it's actually 0 over 1, which is y equals 0. When you box these in to get your horizontal asymptote, the powers have to match. So if you're missing something, you have to put 0 in. All right, number 2, well, we've already done one like this, but we'll do another one. What do we do to find the remainder? Synthetic division. What's going to go in the box? What goes in the box? -2. And then 2, -4, 9, -1. And as I'm writing those down, I'm doing a quick double check to make sure that I don't need to put any zeros in, right? Look at your powers. 3, 2, 1, 0, it's all good. But if a power's missing in the problem, like if it goes from x to the 5th down to x cubed, then you have to put a 0 in. Okay? All right, so what have we got? Did you get -51? Someone match that? Okay. All right. So now we got a y-intercept question. Well, we just did one of these too. How do we find y-intercepts? Plug 0 in for x. So I'm gonna make this a 0. Now, one step at a time. Anything to the 0 is 1. So this is really 28 over 3 plus 4 times 1. This is 1. Anything to the 0 is 1. What's in my denominator? 7. So we have 28 over 7, so the y-intercept is at 4. Some of you forgot on your test yesterday, but what is the first thing that I should do when I look at this problem? I should factor any denominator that factors, right? So look at the last denominator. Doesn't that factor? That factors into x plus 2, x plus 1. Now we're going to multiply by the whole common denominator, which is x plus 1 and x plus 2. So I'm going to multiply by x plus 1 and x plus 2. That will cancel the denominators. So I'm going to do that right now. No more denominators. I have x squared plus 2x, x squared plus 2x, plus 2x plus 2 equals 7. So far, so good. So what do we got? X squared plus 4x minus 5. We want to get it equal to 0. And then I can factor that or use the quadratic formula. Doesn't matter. So my answers are x equals -5 or 1. Now watch that radar. If you put -5 or 1, are you going to have any problems? No. These are both good answers. 1 plus 1 is not 0. -5 plus 1 is not 0. Remember, if it makes the denominator 0, you have to throw it out. But these don't. Okay, now we got one out of chapter P, a long, long time ago. But you've done these many, many times. How did I start? I added the 4 over to the other side. And there are different ways to do this problem, no matter how you do it though. No matter how you do it, you have got to get the absolute value by itself. So that 4 had to be moved over to the other side. Okay? Now, I know how I would do this problem. Now, how would you do this problem?
I switch that negative to positive. Yeah.
No, actually, that doesn't work that way. If you have the absolute value of just a plain number, no x's involved, then you can make that a 5. But when you've got x's involved, no, that's going to stay 3x minus 1. Gavin? No, probably. Well, I can't move the 1 over. as long as it's inside the absolute value.
How you get rid of absolute
Okay,
values?
okay, well, what we did in pre-calculus and what you did in Algebra 2 are two different things. Most of you, when you took your test over this is the way you did it. Now, does that look at all familiar to you? Because the way we did it in class, and I don't care which way you do it, these are both gonna work out fine, you're gonna get the right answer. This is not the, necessarily the calculus approach, but that's fine. This will give you the right answer, okay? We did it like this. I had you divide everything by 3, and then we had x minus 1/3 equals 2. Then we drew a number line and put 1/3 right in the middle of it, and counted here and here. We went 2 units this way, 6/3 that way, and 6/3 this way. So we got the same 2 answers. I don't care which way you do it, but you gotta do it. That problem's on the exam. So you can do it either way you want. Use a number line, or just split it up. When you said how to get rid of the absolute value, you can split it up into 2 separate equations. Notice when you do that though, this part doesn't change. This part stays the same. It's the other side that changes. So 3x minus 1 equals 6, or 3x minus 1 equals -6. And then you solve those equations. All right, if you've forgotten how to do either of any of that, you probably better put a little star next to it. That's something you're going to study. All right, now we're solving a compound inequality. We are not going to make this hard. We're going to make this super simple. We want to get x by itself. So looking at this right here and thinking, I got to have him by himself. What might we do first to start getting x by itself? Add 4. And we're going to add 4 to everything. That is exactly right. Add 4 to every single piece of the problem. So that gives me 2, 3x, and 15. Right? Easy. Now what? Divide everything by 3 all the way across. So 2/3 x and 5 is x by itself. Yep, done. That's it. That's the answer. It's that easy. Now, little caution. This is a multiple choice test, so the answer might be written that way, but couldn't the answer also be written that way? So you got to be ready to see either one. Those are the same thing. Please don't do anything fancy on that problem, just solve it. Like you would do any other equation. Get rid of the 4, then get rid of the 3. All right, here you go. Exam question, 100% guaranteed. What are you going to do to solve it? Quadratic formula. Absolutely. Quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. What's underneath that radical? Plus or minus the square root of what? 33? Does 33 break down? No. It is 3 times 11. But remember, you have to have 2 of something. And you have 1 3 and 1 11, so we're done. That's it. That's the answer. Domain. We spent a lot of time on this at the beginning of the year. When we think about domain, does anybody remember what we have to think about? There are really just two things. Gavin? No, that's a thought. Actually, it would be x minus 2. We would do that on some problems, but not for domain. For domain, we worry about two things. What are the two things we worry about? The denominator cannot equal 0. So the denominator cannot equal 0, which means x cannot equal negative 2. And then the other thing we worry about is whatever is under the radical has to be positive. But this problem doesn't have a radical, so I don't need to worry about that one. This is the only one I need to worry about. Whatever is in the denominator cannot be 0. So in this case, x couldn't be negative 2, right? Now again, no. Multiple choice test. Many of the questions are taken by academic, honors, and college prep. All of us have taken some of the same kinds of questions. This may not be written this way. This may be written like this. Which is exactly the same thing. It's just written in interval notation. So if you work out a problem and you don't see your exact answer as one of the choices, make sure that your answer is there, it's just written in a different form. Double check that. Make sure.
For the test rules, the multiple choice be no calculator and then the other parts be calculator.
All of the no calculator is multiple choice.
Okay.
Some of the free response might be, I'm not sure. I think only I think on this exam, only the no calculator part is the multiple choice part. I know on the spring exam we have some of both, but I think it is all no calculator and then calculator. All right, so that's domain. All right, so number 9. Well, we already did one like this, but let's do another one. All right, how do we find f of x plus 1? Plug in x plus 1 here and here. We plug in x plus 1 for every x. So 3x plus 1 squared minus 2x plus 1 plus 1. Every time you see an x, you're going to put in x plus 1. So this, remember, is a FOIL. FOIL it out. And be very careful on your distributive. Some of you made several mistakes on your test because you just didn't distribute correctly. So this would be negative 2x minus 2. Now I have no idea. I did that kind of fast. Let's see if that's right. That's what you got? actually the same problem as this, it's just written differently. Because what is g of x? X plus 2. So we're really finding f of x plus 2. G of x is x plus 2, so we're finding f of x plus 2, which means we're going to do what? Plug in x plus 2 here and here. So x plus 2 squared minus 3x plus 2 plus what? Again, it's a FOIL. So now FOIL this out. X plus 2, x plus 2. Always when you have a quantity, make sure you're FOILing it. Double check that for me. It's not a oh, that question on your face.
Oh.
Just trying to stay away. Okay, these two problems look different on the surface, but they're the same thing. The arithmetic is exactly the same. All right, number 11 is a sketch. Now, after yesterday's test, I think most of you see the word sketch and you like freak out. This is, what shape is this? Look at it. What shape is this, guys? It's a parabola. How do we know it's a parabola? It's an x squared. Now, we know that parabolas in the ideal situation look like this, right? But there's been some changes in the equation. Where is the vertex of this parabola? 3, 1, right 3, up 1. So your vertex is right 3, up 1. What does that do? Makes it go upside down. Sketch done. No problem. That's easy. Right 3, up 1. Number 12 is another parabola, but it's a little harder to find its vertex. This one, you could look at it and say the vertex was at 3, 1. This one, I don't know. How do I find the vertex when it's not in vertex form? We already did this. There's a formula. Negative b over 2a. So your vertex is going to be at negative b over 2a. So the x coordinate is 2. And then we'll plug it in. And when we plug it in, we have got to resist all temptation. You must square first. So what does this equal? You square first. That's 12. 3 times 4. That's 12. Minus 24 plus 4. So what is that? So your vertex is at 2, comma, negative 8. Now, don't be freaked out by all the language in the next question. We've got an x squared equation, all right? We got our parabola. But we want to move it 2 units to the left. So what do we put into an equation to move it 2 units to the left. X plus 2. So now we're gonna have X plus 2. That would move it 2 units to the left. Would you agree with me? Now, what stretches it by a factor of 3? In other words, where do I put a number to make it taller? In the front? So now I'm just gonna put a 3 right here in the front. Now it's been made 3 times as tall. That number affects the height.
And then plus 1.
And then I wanna shift it up 1 unit. So I just take that guy right there and put a plus 1 in there.
So when you like make it smaller, you still put it in front, but it's negative.
No, it'd be a
Oh.
fraction.
Oh, yeah.
So if I wanted to make it half as tall, I'd put a half out there.
Okay.
Now the next one, I think is one of the easiest problems on the exam, but kids have missed it in the past. So let's make sure I don't shortchange the conversation here. So look at this picture. Okay, here we go. Alright, so it's 1, 2, 3, 4, 5. Yeah, and -1, -2, -4. Alright, so here we go. Name the intervals where the function is increasing. What does increasing mean? Going up. So if you just start over here and you start tracing along this picture, wherever your pencil's going up is what the answer is. So it looks like my pencil is going up here. Would you agree?
Yeah.
It also is going up here. And it's also going up here. Would you agree that the purple, can you see the purple there? Would you agree those are the increasing pieces? All right, so I just write down the intervals. So it starts going up at -3, and it stops going up at 1. So there's my first interval. Everything from -3 to 1 is going up. Or, what else is going up? Everything from 3 to 4. I'm moving left to right, so I'm looking at my X values. What X values have Y's that are going up? Well, everything from here to here, and then everything from here to here. That's the answer. That's easy. So far, I think the whole shebang's easy. Let's see what's next. All right. And again, we're not going to get boggled by the vocabulary. We know what we're doing. Yep.
How do we get out?
What time do we have to leave, Jeannie? 8. Is it 8? Just a minute, let me check on maybe Here it is, all classes. It is 8:40, so we have to go. All right, well, tomorrow we will do as much of this as we can, and remember we have a study session tomorrow night. So we'll pick up here tomorrow. So I will see you tomorrow.